Hi everyone. So let us solve today's problem of the day, that is find transition point. Let us go through the problem first. Given a sorted array containing only zeros and ones, find the transition point, that is the first index where 1 was observed, and before that only 0 was observed. Okay. So what does the question state is that we have an array of elements, right? And we need to return the index of the first one that is encountered in this particular array. And also this array is in sorted order. So that is all the zeros appear before all the ones. Okay, so when we go through the expected time complexity and expected auxiliary space, it should be, we should not take any extra space and we should take a log in time. All right, so when we think about the brute force approach, so before that let us understand the test case which is given. For example, if we have 00011, so what are the index value that I have? That is 0 1 2 3 4, right? So what is the first one, where is the first one that I'm encountering? That is the third index, right? So that is what the answer is, where the first one was observed, right? So at third index I am observing the first one. Okay, at third index I am observing the first one, so this will be my answer, right? uh, so when we think about the brute force approach, okay, when we think about the brute force approach, what can we think is that, let's say we are iterating through this particular array, and anytime I am getting my first one or anytime I'm encountering my first one, I can just return that index, right? So this will be the brute force solution, wherein we will iterate through this particular array. We'll go one by one to every index and check if that particular element is equal to 1, right? If that particular element is equal to 1, the very first time I'm encountering one, I will just return its index. So this is what I'm doing, I'm returning I, and at the end of which we can just check if we have never encountered any one inside my array, because there can be cases wherein we have all the zeros, right? So in that case we should return a -1. Okay, so this was the brute force approach. So what about the optimization approach, right? So I have discussed in our previous videos as well that whenever we are thinking of any question related to array optimization, right, always think about algorithms like binary search or two pointers, or if you're allowed to use any extra space, then we can use something like hash map or set, right? So for example, this question is related to searching of an element, right? We have to search an element and we need to optimize it. So if you know binary search algorithm, you might know its time complexity as log n, and it is also given as the expected time complexity. So we have a lot of hints to which algorithm we have to use, and you're right, we have to use the binary search algorithm, right? So what does the binary search algorithm actually do is that it reduces the search space in at every step. Okay, so at every step we find the mid element and check if it is following our given condition. If yes, then we will return that particular answer, else we will try to reduce our search space, right? So since whenever there is a concept of the sorted array, this is the main keyword of binary search. Okay, so whenever we have this keywords like sorted array and search some element, so always think of binary search optimization. Okay, so coming back to what we will be doing in this particular question is that we have the array in a sorted order, right? So every time we can find the mid element, every time we can find the mid element, and at that particular mid element I can check. Okay, so when is first of all, when is a position considered to be an answer? Okay, so a position having a 1 should be my answer, right? Any position which is, first of all, it should have a 1, because that itself is my answer where 1 is observed, right? So in that case, first of all, I have to check if that particular mid value or whichever value that I am at, if it is having a 1 in its case. And also, when will it be the first one that is encountered? If its previous element is 0, right? If any one is said to be the first one in that particular array, if it's just previous element is 0. Okay, so that is what we will be checking. We will take the mid element, and every time I'm getting the mid element, I have to check. Okay, I have to check if that particular element is equal to 1, and if it's I minus 1th element, that is its just previous element, is equal to 0, so that means that particular one is a transition point, and I will return true, or we will just return the index or mid value. Okay, we will return the mid value. Okay, so what if we have the 1 and its previous element is not equal to 0, right? So for example, if we take this particular one, and what if this particular one was our mid value, and it is having another one at I minus 1th index, right? So in that case, what we can do is we have to reduce the search space, obviously. Why? Because we have, obviously we are sure that our answer exists in our left hand side, right? So in that case, what I can do is we can just set this particular element as low and this particular element as high, right? Or index as high. So I hope you're clear with the approach. So if we are encountering any one, we have to check if its I minus 1th element is equal to 0. If it is equal to 0, that means that particular one is a transition point. If it is not equal to 0, in that case we have to reduce the search space and search in our left hand side. Okay, but what if we have an element which is equal to 0? So let's say we get a mid that is equal to 0. Okay, so in that case we know that we have to go towards the right hand side. Why? Because since this array is sorted, and if we are encountering a 0 and we need to find a 1, so obviously we have to find it in our right hand side, right? So we will be using this particular approach. I will go through the solution once so that you're more clear. Okay, so this is the code we have. We will take two pointers, low and high, obviously, what we do in the binary search approach. So while my low is less than equal to high, what I can do is we can just find the mid. And if that mid is equal to 1 and it's mid minus 1, that is, it's just previous element is equal to 0, we can just return that mid, right? And else if that particular element is equal to 1 and its mid is not, if it is not meeting this condition, it will come to this condition wherein the element is 1 and its previous element is not equal to 0. So in that case we can reduce the space to our left hand side, so mid minus 1. Else we will do mid low equal to mid plus 1, and at the end of which we can just return minus 1 if we are not encountering any mid value which is following these particular conditions. Okay, so I hope you're clear with this approach. Thank you.